Okay, so we're on this serverless topic and will be for another couple of weeks, really. And I introduced the uh, let's call it a concept, I suppose, the last thing. So we'll pick it up from there. We I mentioned that there are a number of services that come under the serverless kind of banner. And the first one that we want to look at is the Lambda service, which is the principal compute service. So, and you've probably heard of it already, I'd say. And you may even have used it. Um, so what I'm saying here is that it's an event-driven serverless computing platform. Serverless, we know, that means we don't have to actually do any underlying infrastructure set up ourselves. It's compute in the sense that we can execute code using this Lambda service. And event-driven means that the code it's triggered or it's executed as a result of some event occurring in the environment, I suppose. And we'll see now as we work our way through this module that the source of that event could be many different things. Uh, the second bullet point is kind of repeating the same thing, really, I suppose, in a way. It runs. Oh, yeah, well, the only thing is that when I talk about the code is actually as granular as a function. Can be that fine-grained, if you like. And indeed, we can deploy a function to the Lambda service rather than, in old school terms, we would be deploying perhaps an entire application. Although we saw in last semester's module, we could deploy part of an application as in a microservice. But a function really is a much smaller unit than a microservice. Um, as well. Sorry, now just give me one sec. What else? Here I'm saying that, and this is kind of an indication of the serverless nature of Lambda, that the Lambda service itself, it takes care of managing the runtime resources that our code needs, i.e., any RAM that it needs, networking capabilities, CPU, obviously. It provides all that um, for us. Here I'm saying another way of kind of interpreting this or understanding this Lambda service is that it allows custom code to run in what I'm calling an ephemeral container. Now, we know what a container is from last semester. It, the runtime environment isn't a fully fledged kind of Docker container, if you like. Now, in the language of Lambda service, they talk about micro VMs. So, which is quite close to a container, but it's even more lightweight than a container. And you'll hear me using that term, a micro VM. So the micro VM is the runtime environment for our function, our Lambda function. And by ephemeral, we simply mean that, when I talked about this event-driven idea, when the event occurs, whatever the nature, the source of the event is, the Lambda service will create an instance of this micro VM. It will load our function into the micro VM, and then it kind of tells the micro VM to run the function. And when the function is completed, it simply throws away the micro VM until the next event occurs, and it goes through the whole process of creating a fresh micro VM again, instance, loading the code and executing it. Um, Now, later on, though, I'll slightly change that story in the sense that if a large number of the same events kind of occur in quick succession or indeed in parallel, then it may actually reuse the micro VM rather than destroying it and recreating it. But either way, it considers these micro VMs to be something that can be destroyed and recreated uh, at will, kind of. Fast is another term that we use for this whole area, function as a service. So this is kind of the very simple look at the runtime environment. You have some source for the event, and that could be anything. It's often another service, another AWS service. Although it could be something outside of the AWS cloud, like it could be a HTTP request. Either way, there is some source that generates the event. Now, the event is actually handled by the Lambda service. This is representing the Lambda service. This is representing the Lambda function. Everything is always going through the Lambda service, and in subsequent slides, you might get the impression that the source is talking directly to the Lambda. That's never the case. So the event occurs. The event is caught, if you like, by the Lambda service, and based on our configuration, the Lambda service will know that it needs to invoke our function and pass the the payload, which is essentially the event, pass the payload of the event to the function. Now, based on what I said on the previous slide, you know, this function is running inside our micro VM. So my box here is representing my micro VM, if you like. The event source, I'm saying, can be many, many things. So we also refer to it as the trigger for our Lambda function. Could be a HTTP request. It could be as a result of some data state change in a database. We'll see that at the back end of this module where we'll have a database, and when the state in the database changes, i.e. a new record is added or deleted or updated, that will actually cause our Lambda function to execute. The database state change will be the trigger or the event source for our Lambda function to execute. Or it could be some other, uh, resource state change. For example, you could link the changing of an EC2 instance's state to the execution of your Lambda. And there are lots of other sources as well. The Lambda function can be written in any language you wish. We will be doing it in TypeScript just for convenience. The Lambda service doesn't really care because the Lambda service doesn't really see the internals of the function at all. It just creates, the Lambda service is responsible for creating the micro VM instance. It loads the function into it, and it's out of the picture really at that stage, other than, causing the function to execute. The Lambda service, well, okay, this is kind of the high level attributes or qualities of this whole Lambda service. I'm saying it's auto scaling. What I mean by that is if there are a large number of occurrences of the event concurrently happening, then what the Lambda service does not do is kind of queue up the events and pass them one by one to a single micro VM. What it actually does is it creates multiple micro VMs, loads each of them with the function, and load balances the events across the multiple micro VM instances that it has created. And once the event frequency kind of tapers off or reduces, then it deletes micro VMs as it doesn't need them. But it takes care of that scaling and load balancing, which is really nice. It takes care, obviously, there's an operating system loaded in the micro VM, and operating systems by their nature, they change and they have to be maintained, patched, and all that. We don't have to worry about that. The Amazon Lambda service and more generally the Amazon cloud will take care of ensuring that the various operating systems that are supported by the Lambda service are kept up to date and maintained. It handles all security aspects. utilization, all taken care of as well. And there are some points over here that you can read yourself. Um, okay, so looking a little bit closer then, so we're really interested in the Lambda function. And here I'm showing you what I'm calling the anatomy of a Lambda function, or the Lambda code. There's actually two parts to it. There's what we call the initialization code, and there's the actual function itself, which we often refer to as the handler, but it doesn't have to be called handler. So this is the Lambda function, but you can have code outside of the function, and that would be classified as initialization code. You can have other functions as well within this overall file, but these functions, the only reason you would have other functions here is because maybe the code inside the handler was just quite long-winded. Um, so you just took chunks of it out and put them into separate functions, just from a code readability point of view. So these would all be kind of private functions that are invoked within the main handler, if you like. The handler function, it's obviously an asynchronous function because it's being executed over the network. Um, it takes two arguments. The first one is the actual event itself. So that's going to be a JSON representation of the event payload. The second argument we never really use, but it would actually give you access to the micro VM environment. For example, if you wanted to create a temporary file on the file system within the micro VM, you could do that via the context argument. But we never do, as far as I can remember. Okay. And I'm saying here the initialization code is executed. It's always executed before the main handler. And talking about cold starts here, I'll come back to that later on. So as well as writing the actual Lambda function, you also need to do some configuration of the function. And the configuration is really what you put into your CDK stack, as we'll see. But in terms of what kind of uh, compute resources that your Lambda function might need, where compute resources now is comprised of CPU, credits, RAM, networking bandwidth. What the Lambda service designers decided was rather than giving the developer the capability to control each of those three different aspects of configuration, i.e. CPU power, RAM, and networking. Rather than giving the developer the ability to control all three of them, what they only allow us to do is to declare how much RAM our function will need at runtime. And based on that, the Lambda service determines how much CPU power it needs and the kind of networking bandwidth that it needs. And it kind of computes those other two proportionally based on the amount of RAM that you have requested. And I'm talking a little bit here about, the RAM. The smallest amount of RAM that you can request is 128 megs up to 3000 megs in batches of 64 megs. So, and then here I'm just showing you kind of the relationship between the amount of RAM and the amount of virtual CPU credits that are assigned to your function. Yeah. So we needn't go into the detail of this now, but so the only kind of dial, if you like, that you have control over in terms of configuration of your Lambda function is the amount of RAM that you want to have allocated for it. The other aspect of configuration that you can also control is what's called the timeout setting. The timeout setting i- is how much time you expect your function to need in order to complete its execution. Yeah. Um, and if your function happens to go beyond that timeout, then the Lambda service will essentially interrupt the function and uh, return an error back to the client, whoever tried to trigger the source, if you like. So, and again, there were some arbitrary decisions made by the Lambda service designers. So they said, look, the minimum, where do I say it? The minimum timeout it can be is 3 seconds. The maximum is 15 minutes. So the idea is that Lambda functions really are meant to only do small types of uh, functionality. If you had a large batch processing piece of functionality that you wanted to implement, you would not implement that using Lambda functions. You'd probably take a more containerized microservice approach towards implementing that. So timeout and RAM are the two main configurations that you have control over as a developer. There and you know there are a couple of reasons why even though you might set the timeout to something, there are a couple of scenarios where the function might exceed its timeout. For example, if your function was trying to make a connection with, let's say, a database or some other service, and that other service was slow in its response, then that's really eating into your timeout. Um, uh, that's probably one of the main reasons why the timeout might be exceeded. You should never really set a timeout. You should always ensure that the timeout that you set is sufficient for the actual amount of, you know, um, compute time that the function would normally need. Whatever normal kind of means, really it depends on the nature of what it's doing. Okay, let's see a simple example. So I have got a CDK project, and the stack is simply comprised of the following. So we saw um, the outline of a CDK project the last day, so I don't need to go through that again. All we need to focus in really on are the CDK stack and the actual Lambda function. This is the CDK stack. It's always in the lib folder. And I've created another folder called Lambdas. It doesn't have to be called that. Some people call this folder functions. And it's in this Lambdas folder is where I will put my Lambda functions. And equally, the Lambda folder doesn't have to be here. Some people put it inside the lib folder. Some people actually call it the SRC folder. There's no prescription at all as to what you call this folder. So we look at the Lambda function in a second, but in terms of the stack, uh, here's how I kind of tell the CDK framework and by implication CloudFormation that I want CloudFormation to create a Lambda function resource for me. And here is and again, this is an example now, another example of an L2 construct. And it's kind of neat, like that there's actually a construct specifically for um, when your Lambda function is a TypeScript stroke JavaScript function, because you can see from the L2 construct name there that this is obviously a function that's going to run on the Node platform, Node.js platform. So it's just a convenience function really, or a convenience method. But overall, it's kind of one of these L2 constructs because as well as creating the Lambda resource, this piece of code will also result in the creation of an IAM role and some IAM policies for my Lambda function. That kind of happens uh, uh, behind the scenes, which again is your kind of classic L2 construct idea. One one piece of stack CDK stack code will, or one L2 construct invocation in your CDK stack results in many AWS resource infrastructure resources being created. Okay, and as I said to you the last day, these L2 constructs, they always have three arguments. The first one is essentially what what is the scope of this construct? And as I said to you the last day, it's always the scope is always the current stack, the kind of enclosing stack. The second thing is just the ID, which is arbitrary. And the third part then is the configuration, which is unique to the particular type of L2 construct. So these are some of the, and only some, of the configuration settings for a um, Lambda function resource. Now, many of them I didn't actually have to specify, but I don't actually have to specify the architecture. I'm not sure what is the default architecture because many of these things have default values. I should have checked what the default architecture is, but I'm just specifying ARM64 as the underlying kind of hardware architecture that I need. I don't really need that. There's nothing special about my function that needs that. The runtime. Uh, Clearly, you can tell here that I'm asking it to, sort of in the micro VM, I wanted to load Node.js version 20 as part of the well, as part of the micro VM's kind of platform installation. Entry, that just refers to the file that contains my function implementation. So I'm essentially pointing it at this file up here. Uh, Timeout, I talked to you about. Now I've set the timeout to 10 seconds. The function does not need 10 seconds on average to execute. I could really have left it at the minimum of 3 seconds, in which case I could have left timeout out completely because the default is 3 seconds. But I'm just being explicit about it for demonstration purposes. And here's the memory size that I was talking about. And again, I could have left this out completely because the default is 128 megs, but I'm just being explicit. And that's all that's in my stack. So I've kept it as simple as possible. Now, the only other thing I have done is this here, right? When I deploy the stack, I just want to output the name of the function to the terminal. And I talked about this statement to the last day that, if you want to output something to the terminal when you deploy it, then you use the CDK CFN output statement to do that. So this doesn't really create a resource as such, and it doesn't really fall into the L1, L2, L3 construct space. Okay, and that's my stack. So oh yeah, sorry. The Lambda function then looks like this. Now this Lambda function does not have any initialization code. If it did, then I would put it here. It would be outside the Lambda function. It would be outside the handler, sorry. And I think I might have said that a while ago. So typically the kind of stuff you might put here is if your Lambda was talking to a database, you would establish the database connection here, right? You could put the database connection code inside the handler. That is just considered bad practice. And I'll explain later on why it is bad practice. Um, but it doesn't arise here anyway. My Lambda function, it really actually only has two statements. It has a console log and it has a return statement. So it doesn't really do anything, right? Um, it And its type is handler. Okay. Um, which I've imported from the library. It's an asynchronous function, and here I am actually, here are the two arguments, event and context, but I'm not actually using either of these parameters in my code, so I could have left them out because that they're not being referenced. I have wrapped the code in a try catch block. I didn't really need to in this case because, there's nothing here that could throw an exception. So I don't really need a try catch block, but again, it's considered best practice, and my catch block is fairly standard. That's my Lambda function. Now I've already deployed it just for convenience. And if I pull up, so this was the result of the deployment. And here's the output. Okay, so this is the actual name that the Lambda service has given to my function. The name is always kind of comprised of the stack name followed by the function name, and then there's just a hash value. That's just the pattern that it follows. So that's the full name. Uh, if I switch over to CloudFormation, or to the management console, sorry, I go to CloudFormation first. There's my stack. Now, I didn't look at let's just go back to here. I didn't look at this file in the bin folder because it's not really that interesting, right? Again, it's always a case of create an empty CDK app, then kind of add your stack to the app, and that's it. Right? There's nothing else in this file. So, and the name I gave my stack is that simple app stack. So that's what I'm getting here, simple app stack. And that seems to have deployed successfully. If I jump over to the Lambda service, and if I look at what functions do I have deployed in my account, there's only one Lambda function. And so this is the Lambda resource that has been created by CloudFormation for me. If I go into it, there's lots of stuff here that about your Lambda function. The only thing that we're kind of remotely interested in now is the code, maybe. If I go to the code, and of course now my TypeScript is compiled into JavaScript. That happens locally, right? The CDK framework does that. So here's the actual JavaScript equivalent of my Lambda function. So there's lots of wrapper kind of code added by the CDK framework. And again, we don't ever need to look at the actual raw JavaScript code, but that is the code uh, that will actually be loaded in. This is the code that's actually loaded into the micro VM. Um, Now, in terms of how can I trigger the execution of this Lambda? Well, for any Lambda, you can trigger its execution using the AWS CLI. And that's really the only option we have in this case. So let's do that. Oh yeah, I must grab the function name because I need that. So to trigger a Lambda from the command line using the CLI, it's just AWS Lambda. and it's this Lambda invoke. And sorry, now let me just sorry, let me just get rid of all of that. Just do it clear, just make it a little bit easier to see what's going on. So AWS Lambda, AWS Lambda invoke, the name of the function, and you have to specify a JSON file for where the output, sorry, where the response from the Lambda should go to. For some reason, it won't actually display. If I leave the JSON file name out, and the file can be called anything. I think it has to be .json, although I didn't check that. If you leave that out, well, you'll actually get an error saying you forgot to leave, you forgot to include the output file. So we need that, and then we just need to give the exact function name. Now, don't worry about this thing that's asking me here. This is just something that's specific to my CLI environment, so you won't get that. Okay, and it's this 200 response is actually coming from the Lambda service. And you can see over here, I have my response.json file, and the contents of that file, the contents is essentially, where is it? The message here, right? Well, the entire contents of this JSON file is taken directly from, my return statement here. Yeah. So that seems to match up because the message was this here, and that's what we saw in the response file, response.json file over here. So that seems to have worked. The only thing remaining though is in my function, I have a console log. And so the question is, where can I see my console log statements or the output from the console log? And the answer to that is they will be sent to the CloudWatch service. So let's bring up the CloudWatch service. Now, lots of services use CloudWatch. Lambda is one of them. And when a Lambda function logs something to the stdio.out, stdio, when it logs something to stdio, then the Lambda service will send the output to CloudWatch. And what CloudWatch does is it creates a log group for every Lambda function. And for every execution of that Lambda function, it will create a log stream within a log group. Okay, so repeat that again. There'll be a log group created by CloudWatch for every function that you have in your account, and for every execution of a function, the CloudWatch will create a log stream entry in the appropriate log group, right? So to see the log groups, if you go down here on the left, just select log management, this CloudWatch service has actually changed, I've noticed, in the last couple of months, really, because there's some AI related stuff here which I haven't had a chance to look at, but I don't think we'll be looking at it either. But down here anyway, if you see the logs part, and if I click on log management, what I'm getting here now is a list of all the log groups that CloudWatch is maintaining for me in my AWS account. Now, uh, as I said there a while ago, there are lots of other services, not just Lambda, lots of other services that use CloudWatch logs. So the log groups are not always linked to a Lambda function. This one though is, and you can tell that from the name kind of that CloudWatch gives to the log group because it's beginning with /AWS/Lambda. That's telling me, well, this log group is actually related to a Lambda function. And the rest of the log group name, this part here, is taken from the actual function name. So this is the log group. Let's go into it and see, are there any log streams? There should certainly be one. This is a log stream. You get a log stream per execution, ish. For now, we'll assume it is. So if we go into the log stream, this is the detail of the log stream. The log stream is made up of a number of parts, okay? And if you look at this bit here, right, init, this part of the log stream is linked to the initialization code part of your Lambda function. Now, if we had console log statements, sorry, now I'll go back to my Lambda function. Where's my Lambda function? Oh, yeah, sorry. If we had console log statements kind of here outside the handler, then you would see those console log statements appearing after this init entry. Doesn't arise in our case though. When you see start, start is represents the beginning of the actual handler function itself. And for each console log statement, there'll be a new line here for each console log statement. End obviously signifies this is the end of the log stream or the end of the execution of my Lambda function. And there is some basic stats about, how long it took to execute, how much RAM it used. And clearly you could use this information to maybe tune your timeout and the amount of RAM that you need. I guess that's the benefit of this kind of information. Now, we only had one console log statement in our function, and that's why there's one entry here between start and end. And if I expand it, and here's the actual console log statement, I was invoked. I was invoked is indeed what my console log statement wanted to log to stdio. So that seems to have all worked fine. And clearly, you would use console logs as a debugging aid, and that's the only debugging aid that we will have available to us. It's not that sophisticated, but it's fine for what we need. Okay, so that's the 101 of Lambda functions. I'll just pause in case there's any questions. No. Lambda integration. What I mean by Lambda integration here is what other services can trigger a Lambda function? And it turns out that lots of them can. It's not just restricted to these here, I don't think. There are other services as well that can. So the overall message is lots of the other services can be the source of the event that triggers the execution of our Lambda function. Now, there are three integration models that the Lambda service designers came up with, right? Synchronous, asynchronous, and what I'm calling pole-based, though they give a different name to it. Now, it's not that you have the option of this deciding whether you want to have a synchronous communication between the event source and the Lambda function, or maybe you prefer asynchronous. No, you don't have control over this. It depends on the uh, it depends on the event source service as to whether synchronous, asynchronous, or pole based is being used. So it's kind of built into the source service that happens to be triggering your Lambda. You don't have any control over it. So I'll briefly talk about, well, what are the different ways that you can have synchronous communication between the event source and your Lambda service. What are the different ways you can have asynchronous and similarly for pole-based? We will see the 2 and 3 later on. For now, we'll only actually deal with integration model 1. And for synchronous integration, I'm saying that the client or the event source, what is it? Oh yeah, well, as is implied really from synchronous, with synchronous integration, the client always waits for the Lambda function to complete, and it waits for the response back from the Lambda function, which obviously means in the other models, the client doesn't wait, but for synchronous it does anyway. And I'm listing here some of the ways that synchronous integration is used. So we invoked the Lambda function there a moment ago using the AWS CLI. So clearly there was you could see that the command line actually waited until it got a response back. So hence there's synchronous communication going on between the CLI and your Lambda function, although really it's the between your CLI and the Lambda service. The SDK, what I mean, like we could write an application that runs outside of the cloud, even on our own desktop. And if we used the Lambda service, sorry, the Lambda SDK, because there is an SDK that we can avail of, we could actually communicate with a Lambda function from within the application that's running on our desktop, let's say, or even a mobile device, doesn't really matter. And the nature of the communication in that case is synchronous as well. So there is a service called AWS Gateway, API Gateway, sorry, which we will use later on. We use this service if we want to develop a REST API, and we will be doing that. So we'll see that later on. You know what a load balancer is from the automated cloud services module that you did in third year? You can actually hook up a load balancer to a Lambda function. So load balancers receive HTTP requests, and you can get the load balancer to route your HTTP request to a particular Lambda function. You can also get the Lambda service to generate a URL specifically for your function, and we'll see that in a second. And so whatever, you can use any kind of HTTP client in that case, could be Postman or just a browser. But either way, that HTTP client is talking to your Lambda function in a synchronous mode. Hence, it waits for the Lambda function to return back. Now, if the Lambda function happens to throw an exception, or if it times out, in other words, if some error occurs during the execution of your Lambda function, well, in this synchronous model, the client, I'm saying should here really, but the client should actually handle the error. It's responsible for handling the error. How it handles the error is completely up to you if you are actually implementing the client. Typically, what a client might do is it might retry the execution of the Lambda, depending on what the nature of the error was, obviously. But either way, the client is responsible for handling the error. So maybe just do a retry a couple of times or whatever is appropriate. The image is just showing you, the different the different sources, event sources for this synchronous model. So this is representing the CLI or the SDK, you know. Now, in the diagram here, I've got a kind of a direct link between the source and the Lambda function, but that's just a convenience, you know. The Lambda service is always here in between. So the client is really talking to the Lambda service, and the Lambda service takes care of invoking the function. The function executes and it responds back. The response could be a 200 response, or it could be an error response. And the Lambda service then sends the response back to your client, which has been waiting for the response to come back. This is representing the API gateway idea, you know, so typically with API gateway, you'd actually have a number of separate lambdas for the different types of requests. So, you know, if you've got a REST API, each function would implement one particular endpoint in your REST API, and you connect them all up to one API gateway. And the API gateway then is responsible for deciding which Lambda should handle the request. But either way, uh, whatever the nature of the HTTP client is, could be Postman, it could be a browser, could be a React app running inside the browser. Um, Either way, the client is going to wait for the response to come back from API gateway, which is really from your Lambda function. And again, the Lambda service is in here between the two of them. Uh, okay. Demo 2. Let's actually use, if I go back, sorry, to here, I talk about function URLs. So you can get the Lambda service to generate a unique URL for your function. That was only something it kind of introduced kind of more recently. The Lambda service has been around for a decade or more, I suppose, really. But this function URL support only came in about maybe 5 years ago, maybe at this stage now. So how do we tell the Lambda service to generate a URL for our function? Well, that's something we put into the CDK stack. And I'm slightly running out of time, but I'll just finish this if might be over time now. So if you have to bail out, that's okay. You can just watch the video afterwards. So if I just uncomment that. So here I'm just creating the Lambda resource, and there is just a convenience method called add function URL. And you can control whether you want the URL to be to require authentication or not, because you can see here in the auth type, if I delete none, if I go dot, there are two options. I don't want any authentication, or I want um, AWS's own SIGV4 authentication, which you might remember from last year. So I'll just pick none for now. And you also have to configure the CORS settings for the URL, which I've just left it as completely open-ended. Um, any kind of client can invoke my function. I'm not creating a new. This is not kind of an L1, L2 construct here now at all. The core construct is this one, which we created up here. Constructs are always linked to, you know, when you do something, like when you have the new statement, or the new operator, I guess you'd call it. That's when you're using an L1 or an L2 or an L3 construct. Okay. Here, all we're doing really is kind of extending the configuration of that construct. And as well, for convenience, I'll output the URL to the terminal. So, and that's it. And if I do CDK deploy, CDK deploy. And again, it's going through that whole thing of generating a new. Now it's asking because I've added a URL to my function, I'm potentially opening up a security uh, flaw. So it is checking with me, am I okay with doing that? And I say yes. So again, behind the scenes, the CDK framework is generating the CloudFormation template, uploading it to the CloudFormation service. All of that good stuff is happening behind the scenes. And that's done. And here I can just grab the URL from here. In fact, I don't need to grab it. I can just click on it. And there's the message. There's the response coming back um, from my function. Okay. And another log stream now would have been added to CloudWatch logs. Let's make sure of that. And then we leave it. So if I just go back to here and do a refresh. Yeah, you can see you've got two log streams here now. So there shouldn't be anything unusual. Yeah, it's just a normal kind of log stream again. Now what I do need to do, I won't have time today though, is if I did want or require authentication um, with the URL, then sorry, now let's see. If I do this, I just need to quickly show you the next day how we actually include authentication with our request. I can no longer do it from the browser, as in right now if I do a quick redeploy, and when the deployment is finished, I'll refresh my browser, but it won't work. Okay, it's done. If I hop over to the browser and just do a refresh, okay, then I'm getting a forbidden. So we need to fix that the next day. In terms of the lab, you can now, in fact, in the lab, I show you how to deal with a, uh, a URL, a function URL that requires authentication. So you can actually now complete this section, this section. You could do this section as well. We haven't talked about DynamoDB, but because these labs are so prescriptive, you could work your way uh, through all of it really. Although I'm not requiring you to. You certainly should go as far as simple DynamoDB. I think for next week. Okay, that's all I've got to say. I'll allow any questions just in case there are any questions before I hand off. I will turn up for tomorrow's lab as normal. So if you need to turn up and have any questions, I hope to be there. No, okay. So I'll talk to you whenever. Thanks. Bye bye.